I hope you are able to see my screen now.
Yes, sir. It's visible now.
Okay, great. Yeah. So welcome back. Today we'll look at the discussion on digital certificates and PKI in bit more detail. So if you recall, I was talking about a set of root CAs which are typically held offline, which basically give certificates for intermediate certificate authorities who act more like a front end and start issuing the certificate to the end users. So we were discussing this in the previous class. So I was mentioning it is basically a chain of trust where whenever your browser receives any certificate over a TLS session from the web server, it looks at the intermediate and root CS certificate that are already installed in your operating system or in your browser to check whether the certificate that you received over a TLS session is valid or not. If so, it says that it is valid, otherwise it alerts you stating that whether you are okay in using this invalid certificate and deal with the consequences related to the security. But very often, yeah, they don't let you to go through have a communication whenever the certificates are having any issues. So we were discussing this part in the previous class, and I was also talking about root stores that are maintained in operating systems and browsers. I was also showing you a screenshot of this kind. This is an example of a Windows 10 machine where Microsoft installs different root certificates and intermediate certificates belonging to the certificate authorities which Microsoft thinks are trustable. Again, it is up to the organization to decide which one they want to install as part of their root store programs. If you look at Apple has their own program, Mozilla has its own program, and Microsoft has its own program. So it need not to be the same thing in all these different root store programs, but in general there is a consensus. If you look at the link at the bottom of this slide, which basically talks about a common certificate authority database which contains all root and intermediate certificates of different certificate authorities which are kind of trustable provided that they follow a certain guiding principles that are mandated by something called a CAB forum, that stands for certificate authorities and browsers consortium, which basically different companies and browsers came together. They came up with this particular forum which decides which can be trustable, which may not be trustable. Currently, if you look at, there are 150 plus root certificate authorities out there, and at the intermediate level there are 3000 plus certificate authorities which issue millions and millions of certificates. So far I don't know whether it is clear to you or not. I was so far talking about the certificates in the context of World Wide Web. That means when you're talking about HTTPS communication, where you wanted to have a secure communication with a remote web server, where we need something called TLS or SSL certificate. So these are the certificates. That's what you use when you are accessing your browser as well. And also we use this certificate even for other purposes. I will come back and discuss during the later part of today's discussion. And let's come to today's topics. If you look at here, so there are three different categories of TLS certificates a web server can obtain. If you see here, so there are three different categories of TLS certificates. And the first one is a very simpler one where you can get a single domain certificate, very similar to the way I have shown in previous class, the certificate of our CSE department and IIT Hyderabad main website. So there, if you go and look at the common name field, there you will find csc.iith.ac.in. And we also have one more certificate for the main website that contains iith.ac.in. This is the domain name. And also you see these domain names also mentioned in the subject alternative names. In general, this field, the extended field, that is useful, especially when an organization is having multiple subdomains or when the organization is requiring some wildcard certificate. That's what you can see here. So before we started using latest encrypt based free certificates, we used to have one wildcard certificate from DigiSet. So like star.iith.ac.in, and that got expired, and since we felt we can live with free certificates even though their lifetime is only 3 months because of ability to automatically renew them, we started using separate certificates for various websites that we have kept in our institute as of now. But earlier we used to have this kind of certificate. And if you look at the wildcard, we can have wildcard only in the first part of the domain name. If you look at the fully qualified domain name, only here you can have the wildcard character. You cannot have it somewhere in the middle. So this is also valid, CSE star.iith.ac.in, where you can have CSE 1, 2, 3, 4, whatever it is. So this comes under wildcard certificate. And larger organizations like Google and Amazon, they may be interested in having something called a multi-domain certificate, which are also called Unified Communication Certificate. In other words, it is also called this one, SAN, that is Subject Alternative Name Certificate, which allows you to have up to 500 unique domain names listed under SAN field that is there in the digital certificate. An organization that is hosting a lot of websites, for example, GoDaddy, which also one of the web hosting service provider. For example, if you look at Google or Amazon, or many organizations which have hundreds and thousands of websites, they don't want to end up getting thousands of certificates from different certificate authorities. That becomes quite cumbersome to getting the certificate issued and renewing them on time and all. So to address this problem, very recently we have this multi-domain certificates where under SAN field we can list up to 500 different unique names. I will show you here few where you can see. Not here. Yeah, for example, look at this particular website that is of National Security Agency in United Nations. Sorry, not nations, United States of America. Okay, and if you look at their certificate here, this is issued to like defense.gov, and if you start opening here under the subject name, you can see the common name, that is defense.gov. But if you come and look at the subject alternative names, look at how many different domain names the US government is maintaining. For all of them, they are using a single certificate. As you see here, there's a large number of things that are listed out here. So you can use that. There is no restriction. Up to 500 it is allowed. So look at here. And also it is possible for an organization to also have wildcard domain names here. Like one can have something like star.defense.gov. That is also possible. But in this case, all of them are fully qualified domain names without any wildcards that you can see here. So it is possible to have, but of course they will cost a bit more when you try to apply for such certificate, but yeah, it is possible to get all these kinds of certificates. And so let's look at what are the steps that are involved when a website owner or the administrator wanted to get a certificate issued and use that for secure communication when the web server wanted to communicate with the different clients. So from the user side, which is on the left hand side, you can see that you generate a key pair. Out of that, you take only the public key along with your credentials, send to the certificate authority by creating something called a certificate signing request. So you create CSR request and you send it to the certificate authority. So it is a job of the certificate. How do you send? Again, you can, there could be an online portal in which you can submit this one, or you can generate the CSR using OpenSSL toolkit, and you can send it by email to the email address of the certificate authority. There could be any different means, or you can visit their office and you can submit over pen drive. All these are different possibilities that are out there. Once a request comes, the certificate authority has to verify the credentials that are submitted by the users. So there are different means of verifying the user identity. So I will talk about how Letters Encrypt has made it automated, most of these steps. But whenever you are talking about organization like e-commerce website and banking, when they want to have certificates, they have to go through a rigorous identification process before a certificate is issued to you. Then the certificate is created by the certificate authority, which is nothing but the public key of yours, which is signed with the private key of the certificate authority. And that's what you can see it here. So the public key of the website owner or the website, and some details about the certificate authority which is creating the certificate, some user details like a common name, alternative names, and the validity of the certificate on that, and it is written to the user through one of the means that are possible out here. So that's how you obtain a digital certificate. And once you obtain, depending on the kind of web server software that you are using, if you are using Apache web server, then you have to specify in the certain path, and you have to keep your digital certificate, so that as part of the TLS handshake, the web server sends the certificate to the client, so that client can check validity of the certificate before start having a secure communication with the web server. If you look at a typical life cycle of any certificate, it involves different phases. All the way from the key pair generation, certificate issued, we start using the key pair for secure communication. That's what so far I was talking about. You have installed the key pair and you keep the private key with you. And I mean, when I say you means Alice or the web client or web browser. So you are using it, and Alice the web client gets the certificate of the web server, not that Alice requires a certificate. Even though it is possible, even the clients also can use certificates so that we can get rid of usernames and passwords, but that is a different issue. But so far we are talking about the web server having a digital certificate which is sent as part of the TLS handshake to the client. So here the key pair generation from the web server side and certificate issuance by the certificate authority, and the web server started using the key pair so that it can communicate with the different clients. And if the certificate expires and if the key pair lifetime is exceeded, then you recertify and a new key pair is generated and the key certificate is reissued. That is one case, that is a normal case. And abnormal case is if the private key of the web server is compromised. If you look at, again I will talk about as part of the TLS handshake process later as well, the web server has to maintain the private key.
Sir, what's the difference between private key being compromised and key pair lifetime exceeded?
What is the difference between private key compromised and the key pair lifetime
Key pair lifetime exceeded.
So whenever a digital certificate is issued, if you recall, every certificate contains lifetime, right? If you maybe is it?
Yeah, I understand that, but like, how do we know? Like, the certificate has a lifetime on it, but
Yes.
like, how exactly do they calculate like lifetime? Is it a fixed value or varies from
No. I think
certificate to certificate?
no, Vijay. So if you look at here,
No. How they mark like, let's say 10 years from now, they directly give a date, or do they use some other analysis to give the date?
So can you see my screen here?
Yes, sir.
Can you see this one?
Yeah.
valid from valid to.
Yeah.
So that is the what I mean by validity of the certificate. So if you look at here, this certificate of the NSA is valid till 29th April. If this organization fails to renew the certificate by 29th of April, and if you started visiting this NSA website on 30th April, here you don't get this certificate is valid. Like here you can see that certificate is valid. Where you can see, yeah. Here you are seeing that certificate is valid. Can you see that?
Yes, sir.
If NSA doesn't renew their certificate by 29th of April, here you can see the status as certificate is invalid or the certificate has expired. You got the point, Vijay?
Yes, sir. I understood.
So this is already mentioned in the certificate. So whenever certificate authority issues, they put their timestamp on the day they are issuing the certificate, and also they mention what is the time period over which the certificate is valid. So that is one of the things. And the second thing that is even more important is I was talking about the private key is compromised. Let's assume that you are the administrator of the web server, and somehow you come to know that somebody breached the security of your web server and hacked into your system and did something mischievous, and you don't know whether that guy really has stolen your private key, or you suspect that the hackers have stolen your private key, or you have issued private key to one of the administrators who has recently left your organization, and that person who left your organization still has access to the private key. To be safe side in all these cases, the website owner or the administrator of the website contact the certificate authority and informs to them that looks like my private key is compromised. Could you please reissue the certificate? So this is a other scenario during which we also have to reissue the certificates. Any questions from anybody on the private key compromisation?
Sir, during this compromising and then reissuing request, the web server will create another key pair and it have to go through the earlier cycle of approvals again.
But they don't have another key. See, key pair is one thing. See, as a user, you can have any number of key pairs. But public certificate is different from the key pair, isn't it? Certificate is nothing but somebody attesting that yes, so and so is indeed your public key. So if somebody's private key is compromised,
Okay, so now the certificate has to be issued for a different public key, right, sir?
yes, the client will again
Yeah,
submit
that is,
a new private key.
yeah,
Again, as you
yeah,
see,
yeah,
that
yeah.
it is a pair. Once one private key is compromised, you also better
Yeah.
change your public key because it is a unique combination of private and public keys that are involved.
Yeah. That's what my question was.
Yes,
Yes,
yes.
sir. Yeah.
Yeah, you have to, if you look at here, the new key pair is generated. You can see it here. Yeah, this is the point.
Yeah. This will be done by the web server and then it will be sent across to the certifying authority.
Yeah, only the public key you have to send to the certificate.
Yes.
Yeah.
Yes, sir.
And
Thank you.
so a related question that somebody may be thinking about is where the private key is stored in the web server. So does anybody can guess how the private key is stored? So look at our CSC department website or the institute website. How do you think our system administrators are saving the private key? How do you think? Any idea? So there are two broad approaches in saving the private key. One of the most common thing is whenever you use utilities like OpenSSL and generate a public and private key pair, the tool also lets you to encrypt your private key with a certain password or some passphrase, whatever you can call it. That way, your private key is stored in your web server at any location that you can store. But only thing is you have to specify the location where the private key is available as part of the website configuration. If you are using the Apache, then use http d.conf file and you specify where your public key and private key are located. But in this case, if you password protect your private key, whenever you reboot your web server, then the launching process of the web server get stopped and you are prompted to enter the passphrase that is used to decrypt the private key. After that, the private key is stored in the main memory, and during the service of the web server, from the main memory, the web server uses the private key and uses it for the secure communication, where the client will be using their credentials by encrypting them with the public key of the web server. In that case, the web server uses the private key to decrypt it and use the credentials supplied by the client to check whether user has the proper authentication credentials to access the website or not. That's how the private key is used. That is the typical usage. But as I was mentioning, when you put the password, then whenever the web server is rebooted, you have to, whenever I'm using the word web server, it could be either physical rebooting of the hard rebooting of the server, or it could be relaunching the HTTP daemon. So in either of these cases. That way, if your website is compromised or your web server is compromised, even if the attackers get to hold of this private key, they cannot do anything, provided that you have a password of a certain length. Higher is the password length, it is more better. So other approach that is also commonly employed is you don't encrypt your private key, but you make it your private key. You make your private key accessible only for root user in the read-only mode, and don't let anybody to log into the server using SSH or any other remote login with root as the login. That means as the root user, you have to physically go to the server and log in with the console that is out there and keyboard. Remote login typically is disabled for the root user. That way, attackers may not be able to get hold of that. So these are two different approaches, and especially when I'm talking about the multi-domain digital certificates where 500 different websites are using same digital certificate, I'm talking a scenario where there could be potentially 500 different web servers which are storing the same private key in their respective servers. So the probability or the chance of your private key getting leaked or compromised will be higher as you start using it for more and more websites. It could be like subdomains or it could be different multi-domains. That is one of the main reasons why you can see of late the lifetime of the certificate has been significantly reduced and the process of renewing the certificate has been simplified to greater extent so that we can remove the administrator from the whole process, so that let web server and the certificate authority, whenever I'm using the certificate authority, in this context I'm talking about certificate authority is more like a server which is interacting with your web server for renewal of the key or the revocation of the keys and whatnot. So that is the most common practice that is followed of late.
Hello, sir.
Yeah, please.
So if the private key is compromised and if we notify the certificate authority, so till then the web server will be down, like this process may take some time, right?
No, why
So
do you think? No, again, when you say web server is down, that is as the administrator, that is the first thing that you should do. Because if you don't shut down your web server, what could happen is there is a chance that your private key could be used by some hackers and they could use it for different purposes like financial gains or phishing attacks or whatnot. You are right. If the private key is compromised, you better shut down your server till you get a new certificate issued and you restart your server with the new certificate. Yeah, you are right.
okay, got it. And one more query is there. If we are taking the certificate for a domain, is there any restriction to host the number of pages in that particular domain?
No, nothing. I was saying that forget about a domain. You can have 500 different domains with a single certificate, where these 500 different websites may be running on 500 different computers spread across the globe on different IP addresses too.
Okay, so if we are paying for to get the certificate for a domain, so like if I take the example of IIT Hyderabad, so they created the web means domain for a particular departments, right?
Yes.
So if we are paying for this, why can't we just link that to our root domain for IIT Hyderabad and / computer science department and other? So
No, I
that
didn't
will be
get.
less
See, Rahul, of late, the way we are doing is we are doing this one. So currently we have this fully qualified domain name-based certificate issued by Letters Encrypt, which is giving free certificates. We are not paying anything, but we used to pay earlier to DGCET, where we used to have wildcard certificate. In that case, what we used to have is csc.ith.ac.in, w.ith, and all of them used to have a single certificate. One key pair is used in all the website of the institute earlier days. Now, each website is having its own public certificate, the digital certificate issued by Letters Encrypt. We are not paying anything.
Okay. So if we are taking the means wildcard certificate, so like we can host any number of website related
Yes,
to
yes.
this too.
Yeah. You can have any number of subdomains. There is no limit as such. There is no.
Okay.
But as again, the point I was trying to make here is whenever you have the wildcard certificates or multi-domain certificates, you should have more trust on the system administrators. Or you should have more background checks, make sure that your private keys are not compromised. So one way that is addressed or kind of implemented is by reducing the length of the certificate to only 3 months. That's what Letters Encrypt is doing, and automating the process of the renewal so that there are no humans involved. And in spite of these certificates are used across to so many different domain names.
Okay.
So any other queries from anyone? And when the certificates are revoked, what happens is the certificate authority maintains a common URL that you can also see as part of the digital certificate, where they update which certificate IDs are the one that have been revoked. That way the web servers are not web server, the web browsers, the browsers also have to do a periodic check on visiting these URLs where the certificate revocation lists are maintained, and make sure that this certificate is valid or not. That is one of the check. So as part of the assignment, if you recall, I was asking you to write a small pseudocode which basically checks whether the certificate is valid or not. So one of the step is you have to check whether the certificate has been revoked by a certificate authority by downloading the list of certificates that have been revoked at that URL. And okay, so I think I think I was already talking about this. If you look at here, the certificate, the CRL distribution points are nothing but URLs at which the certificate authorities publish periodically the revoked certificates. Okay, and your browser have to download all these details so that they have to check whether the certificate is valid or not. One of the problems that may happen could be, what if the CRL server is down? In that case, then your browser is in a fix. It is not able to figure it out, or it may use the previously downloaded list and say that, okay, certificate is valid or invalid based on that. That is one approach. To address this, of late, rather than relying only on CRLs, that is certificate revocation list, a new protocol that has been followed for checking the certificate is valid or not, or whether the certificate is revoked or not, that is called OCSP, Online Certificate Status Protocol. Here, your web browser need not to download any certificate and search them for validity of your certificate, or whether the certificate is revoked or not. Here what happens is, look at here, each certificate authority not only maintains CRL list at a well-known location. They also maintain another server that is called OCSP server. In this case, the name of the server that I think this is what DigiSet is maintaining is named as ocsp.digiset.com. Here what happens is your web browser queries this particular OCSP server asking whether your certificate of so and so website is valid or not. Basically, you are checking the health of the certificate by querying this OCSP server. The server has to say yes or no. That is the only thing the server does it. So that way, in this case, you don't really have to download the CRLs. Only you have to query the OCSP server. But having said that, whether you are downloading the CRLs or whether you are querying OCSP server, there is an additional delay that is involved because your browser has to now talk with OCSP server over a secure connection and figure it out whether the certificate is valid or not. So there is an additional time delay involved. To address this, a new solution that has been proposed that is called OCSP stapling, where as the dictionary name suggests, here what we are doing is the most recent status of OCSP of a given web browser. Sorry, not browser, the web server. Sorry for the confusion. The most recent OCSP status of the web server is stapled with the web server, and the web server will send that information to the web client, that means the browser. So if you look at the example of Alice and Bob, let's assume that Alice is visiting, which is Alice's web browser, visiting a web server, which is Bob. So there are two ways Alice can check whether the Bob certificate is revoked or not. One is Alice is querying the CRL. Alice is downloading the CRLs. As I was mentioning, like Alice can query the CRL, like in this case, Alice can download this particular list and check whether the certificate is revoked or not. That is one approach. The second approach is Alice queries OCSP server and get to know what is the status of the Bob's digital certificate. That is the second approach. But in this case, we are asking Alice to talk with OCSP server. A solution or optimization that has been proposed is, rather than Alice is asking certificate authority to tell the status of the Bob certificate, what is being done here is Bob himself is saying the most recent status of his certificate when Bob is sending the digital certificate to Alice. So if you remember, or if you just understand, when Alice and Bob wanted to have a secure communication, Alice gets the digital certificate from Bob anyway. So while sending his digital certificate, Bob also sends OCSP status of his digital certificate to Alice, so that Alice need not to has to query the OCSP server. That way we can able to speed up the time taken to check whether the certificate is revoked or not. So that has been followed of late, and I've been checking our institute websites. We have not implemented OCSP stapling in our web servers. Maybe we can do that. But can somebody think of any issues of stapling? Can you think of any issues? Because now we are asking Bob to tell whether his certificate is revoked or not. Can somebody say, does it have any issues?
So even the certificate is revoked, the Alice can, Bob can tell Alice the certificate is not revoked likewise. So, because we are checking at the end of Bob, not the Alice.
Yes, you're right, Rahul. And can you also suggest a solution to fix it?
The best solution what I can find is checking the OCSP server. The best thing, because
you're right,
there is
you're right.
central.
What you are saying is you not only get the status from the Bob, you also query the server. And what you are trying to say that is, okay, as soon as I hear from Bob, I will start communicating with Bob. While I am doing in the background, I will check whether the certificate is revoked or not. And if it is revoked, I will stop communicating. Is that what Rahul you are suggesting?
Yes, but still, like you mentioned, there will be delay. So still the delay will be still there, right?
Right.
Because we are again querying the server.
Right. So what is the solution? Can somebody suggest a solution to fix this?
Sir, stapling can also be digitally signed by the authority.
Stapling can also be digitally signed by whom?
Certifying authority.
Yes. And you are right. Who is it? Jagmeet. Right? Okay.
Yes, sir.
Yeah, you are right, Jagmeet. That's what indeed followed. What happens is when Bobby is, see, I'm talking about Alice querying OCSP server to check the status of Bob's digital certificate. So, as part of the OCSP stapling, what Bob indeed does is Bob queries OCSP server and gets the most recent status of his digital certificate. When the certificate authority is sending the OCSP status, the certificate authority digitally signs the OCSP status and gives that to the Bob. So when Bob is responding to Alice, Bob is indeed sending to Alice the digitally signed OCSP status given by certificate authority. And anyway, Alice has the public key of certificate authority so that Alice can verify whether the integrity of the message is compromised or not. So with this, we can able to get rid of one more TLS handshake from Alice to the certificate authority and able to exchange communication with Bob at the rate at which the communication from Alice and Bob would happen. So that's what the benefit that you can get with OCSP stapling.
Sir, even if there is OCSP stapling, Alice should again query CA if this new certificate is correct or not.
No, why? No, why, Harsha? See,
Like, if Bob tries to like fake that the certificate, even though it was revoked, it's still stapled. Then Alice has to. There's no way Alice knows unless she talks to certificate authority.
are you trying to say Alice? No, I
Will
didn't
talk
get.
to CA
I didn't
also.
get. Harsha, you are talking about Bobby is lying here, or Bobby is what is the
Bob
scenario?
is lying here. Like Bob is lying that OCSP stapling says it's still not revoked. So Alice has to.
No. But what I'm trying to say here is, Harsha, there is no way Bob can lie here because OCSP's status that Bobby is giving is indeed the one that certificate authority has digitally signed.
Yes, sir. So to check this digital sign again, Alice has to ask CA, right?
No, why? Because see, you know the digital signature means what? There is the status which says certificate is, let's say, valid, and it is digitally signed by the private key of the certificate authority. Now tell me whether Alice has the public key of the digital certificate authority.
Yes.
She already has it. What she has to simply do is she has to decrypt uh, the signature with the public key of the certificate authority and see what is inside that is exactly the same as the OCSP status that is sent in by Bob. If both of them are matching means it is not compromised by Bob. It is indeed what a certificate authority has sent to Bob.
Yes, sir.
Got it?
Hello, sir.
Yeah.
So means how frequent the updation in OCSP server is, because daily there is millions of sites and millions of domains. So the updation is like at every second, or means every hour there is updation in the revocation list. So how frequent it is in updation on the server?
You are talking about the certificate authority OCSP server, or you are talking about the web server? Which servers you are talking?
OCSP server.
See, whenever any certificate is being revoked by the certificate authority, then they update in their OCSP servers.
Okay, so
But having said that, don't think that revocation is that widespread. See, revocation is like a rare event. It is not like a most common thing that happens very often.
okay.
So with that, we can able to live with this. But having said that, do you know what most of the web browsers do? They use all these schemes. That means they use the CRLs, they also use OCSP, and also they check whether there's a OCSPC stapling is there. So they try to get the best of all these three schemes that are out there, so that we can able to check the certificate is revoked or not, and able to quickly start getting secure communication with the web server. So it's not that they're not like mutually exclusive. They are like a complementary solutions. Browsers actually doing both of them.
Got it.
Sir, how frequently the web servers will query the OCSP and cache asset?
Yeah, that is also an important query. And see, again, it is also a kind of configuration issue. And again, your question is how frequently the web server has to query it, right?
Yes, sir.
And see, again, even I don't know how frequently they indeed query, but what I expect is, as I was mentioning, in case whenever the web browser gets OCSPC status from the Bob, and if the timestamp of when that particular status was given is, let's say, quite older, then Alice indeed can start querying with the OCSP server, right?
Yeah.
Okay, that is one approach. And other approach is, even if there's any problem in the OCSPC server, the Alice can anyway look at the CRL list that could be downloadable from some other link. So that way there are multiple schemes or multiple mechanisms using which Alice can start figuring it out whether the certificate is revoked or not. But from the web server point of view, again, I have not seen what is the configuration setting. I don't know whether it is really varying from certificate authority or not. But I don't think it is quite that frequent, because see, certificate revocation is like a rare event. So you don't do that quite often.
Okay, so it is like irrespective of whether we get the staple status from the server or not, all the web browsers are doing it there, and the cross-checking is being done. Not immediately during the handshake establishment, but during the process, they are cross-checking with the CRL.
No. You see, you cannot start the communication with Bob unless
Because sir, the very need for the stapling is to make sure that the certificate status is valid and not revoked, right?
not
So
revoked, and you don't have to end up talking with the certificate authority to check the status of revocation.
yeah, so then what my doubt was like, sir, if the servers are not querying oftenly and keeping it up to date, then if we expect Alice to do it, then why the whole process of stapling came in?
Yeah, you are right. Yeah. You don't get any benefit of stapling. You are right.
Yeah.
You are right. And again, I don't know how they really deal with this issue, but you are right. Yeah.
Okay, sir. Thank you. Maybe we'll look into it, sir. Yeah, thank you.
Yeah. So it could be some configuration thing somewhere. Maybe one of the extension field they might have specified when they are issuing certificate to the web browser that this is the frequency at which you should be querying the OCS server and maintain the cache and send it to the clients. Something of that. There could be something of that, but I have not seen that.
Okay, sir. Thank you.
Okay, let's quickly discuss about.
So,
Yeah, Rahul, go ahead. Yeah.
Yeah, so in this particular case, the OCSP server is of DigiSet. So every root authority maintains its OCSP server, right?
You're right. You're right.
Or is there any
No,
central
no, no, no.
authority
No.
for
There's
handling?
nothing like that. Every root server are has to maintain this OCSP server. Yes,
Okay, okay.
they have to maintain. Yeah, and also if you look at here, each certificate authority maintains multiple CRLs, certificate revocation list, and when the certificate is issued to a web server, the certificate itself mentioned the location where the web browsers have to query to figure it out whether the certificate is revoked or not. In other words, a given certificate authority may maintain several different CRLs, but a given certificate, whether it is revoked or not, will be maintained in one of those URLs, so that browsers need not to go through downloading all the CRLs. Only the CRL that is mentioned in the digital certificate of the web browser, they have to download it and check whether the ID of the digital ID of the certificate is mentioned in that or not. That way we can simplify some of the effort. Okay, so let me conclude today's lecture by also talking about Let Us Encrypt and how we can use ACME protocol to automate the issuance of the certificate and the maintenance of the certificate. So as I was mentioning, Let Us Encrypt is giving free certificates because it is a non-profit organization called ISRG is the company behind Let Us Encrypt. Their idea is how to make it more democratic, and so that even the small players who launch their website can also have digital certificate, so that it's not that only the commercial organizations who have hefty pockets can have digital certificate for the secure communication. They want every website on internet to use HTTPS. So one bottleneck is you have to purchase digital certificates. It may cost few dollars every year. So they address that big issue. And another issue that I was talking about is a renewal of the certificate, revocation of the certificate, reissuance of the certificate. All of them are very often involved system administrators, and there could be a chance of mistakes happening, and timelines could be quite higher. So that has been addressed with ICME. So after it, this also has become RFC. So you can visit what this RFC is saying in detail. And to make it the entire process automatic based on ACME, there are lots of tools, again open source tools that are available. So if you are having a web server and you wanted to use Let Us Encrypt, so you have to install these tools whose job is to make it automatic to install and maintain your certificate. Let's explain quickly how Let Us Encrypt gives the certificates. There are three different means that Let Us Encrypt certificate authority follows to verify the validity of your domain name. For example, let's take this example. Let's assume that you are the owner of a website named example.com. That means already you went to one internet registry and have purchased this domain name, and also you have associated some static IP address with this domain name, and you also have your own authority to DNS server which is having a record or Fourier record which maps this particular domain name to the IP address. So all of them has happened already, and now what you are trying to do is you wanted to make your web server secure by using HTTPS rather than simply using the plain text based HTTP. So Let Us Encrypt and this ACME protocol comes into picture after you launched your website having your own static IP address and with your own domain name. For example, in this case, I'm assuming this is your server which is having certain IP address assigned, and the domain name that you have with you is example.com. So, and now you wanted to get a free certificate issued for you from Let Us Encrypt. So here, as I was mentioning, there are three different ways in which Let Us Encrypt certificate authority validate whether you indeed have the credentials or the rights to get the domain name on your name. So there are three different ways. Let us encrypt checks whether you have this ownership of this domain name or not. So the first of these three is called HTTP challenge. In this case, what happens is let us encrypt asks you to put certain file or a certain token at a specific location on your web server, and also ask you to sign a token, like in this case some string that certificate authority sent to the web server, and ask you to sign it and send it back. So, and there are two other methods, and the second one talks about installing a temporary certificate at a specific location on port 443, that is specific to HTTPS. And the third one, which is helping you to get wildcard certificate, is you have to add certain record in your authoritative name server. So if you are a network system administrator, you also be having your own authoritative name server in your organization, or maybe you will be relying on third-party DNS servers. In that case, you have to talk with them and have a certain record installed. Basically, all this to prove that whoever is requesting to get a digital certificate issued for this domain are indeed having the credential to get the certificate and maintain the web server. It's not that some XYZ is asking to get a digital certificate on behalf of your web server. So that is the thing that we want to address. Let me talk about in detail how we can use the HTTP challenge where the web server can prove its identity of owning that particular domain name. So the step one is you are basically making a request. This is where you are saying that I wanted to get a digital certificate for example.com. What certificate authority is doing is, can you please put this file at location so and so, and also sign this token and send it back to me. Okay, so that is what is happening here. How the domain name get validated here is this way. After you get these instructions or the challenge request from the certificate authority, there is an agent that is running again. So I didn't tell about that part. So you can assume that there are three players here. One is the certificate authority, other one is the web server, for which you have a private key and public key, and you want to have a digital certificate issued for the public key of the web server. As part of the ACME, you also install one agent for automatic renewal and issuance of the certificate. Let's call it as let us encrypt our ACME agent that is installed inside your web server. So even that agent also will have a private and public key pair. So that way, let us encrypt certificate authority and the web server which is having private key and public key, and there is an ACME agent which is also having a private key and public key. So this agent is the one that is talking on behalf of the web server with the let us encrypt certificate authority and doing all these activities. So here the first step is to check whether the key pair that agent is using is an authorized key pair or not. So how that is achieved is, again, as I was mentioning, the certificate authority asks the client or the agent to do these two activities. So after receiving the instructions, the agent is putting this file at so and so location, at this location on this URL, and informing to the latest encryptor that I have kept it, could you please check it. That is one of the things that is doing, so that certificate authority visits that particular URI and checks the specified file is present there or not. That means whoever you are talking with that indeed has privileges to install a special file in the path that is specified here. That is one thing. That means one challenge has been met or has been responded to. And other thing is the agent. Here A stands for agent. Agent is signing the token given by certificate authority. And agent also is giving his public key. After receiving the public key of the agent in plain text and also digitally signed token, the certificate authority can decrypt the digital signature with the public key of the agent and check whether the token that is inside is matching with the token that certificate authority sent in the first place. If both of them are matching, means the agent is indeed having a key pair. That means he has the public key corresponding to the private key that is used here. So we call this key pair, that is the signed private key and the public key that is being sent in the plain text to the lattice encrypt, as the authorized key pair, where the agent is having the privileges to get the certificate issued on behalf of the web server. Okay, that step is done. So after that, the certificate authority, after that the agent, after all these steps, that means, as you see, after you sending that, lattice encrypt said that okay, now you have the authority to get the certificate issued for the web server. Now the agent is starting the certificate issuance process. This is exactly what I was talking about earlier, where there is a CSR, that is a certificate signing request, that is generated. So this is the request. Basically, domain name, that is the common name of the website, and this is the public key of the web server. This is digitally signed with the private key of the web server. So look at here what is happening here. The CSR is signed with the private key of the web server. The whole thing is again signed with the private key of the agent. So that is here, the symbol that you see it here, the circular S and the circular A stands for this document is signed with the private key of the web server, and the whole thing is, the whole CSR is signed with the private key of the agent. And already certificate authority knows what is the private key of the agent because that was received earlier. So with that, it will decrypt this and also check whether it is compromised. As you see, digital signature used for integrity, authenticity and non-repudiation purposes. So all that are done. After that, it checks the whole thing and it is signed with the private key of the web server. And as you see, web server anyway has to specify what is the private key. If you look at in all the digital signatures, the entire document is sent in plain text plus a small digital signature is attached. That way, the S, which stands for the private key, the public key of the web server, which is also now known to the certificate authority, and it is and a small digest is generated and that is digitally signed with the private key of the web server. Now let us encrypt after receiving this thing and by using the public key and decrypt it and make sure and confirm that message is not compromised. Then it takes the same, basically takes the public key and the name of the certificate name of the web server and it digitally signs with the private key of the lattice encrypt and sends it to the web server. So this is how the certificate issuance works. And any questions from anybody? I hope this part is clear, even though I'm trying to rush up a bit. Any queries?
So the agent will have to run with full privileges.
Yes, you're right. The system administrator or the web administrator has installed the agent in the web server.
And, yeah.
And if you look at how the revocation process happens, here also the agent sent the revocation request saying that, okay, this is the digital certificate of mine, which is signed by the private key of the certificate authority. Now I am asking you to revoke this, and the revocation request is digitally signed by the private key of the agent. Since the certificate authority knows the public key of the agent, it checks whether the request is genuine and it is not tampered with, and enters this into either in both of the CRL and OCSP server. And After a while, this information will be percolated to the web browsers and the operating systems which are participating in this whole process. And there are also lots of tools that are available online to check how strong and whether there are any vulnerabilities and whether the certificate is valid or not. And we have seen ASN.1 parsers and other debuggers in the previous class, but DigiSet and SSL Store also have many other online portals where you specify the URL of the website whose certificate that you wanted to check. They instantly tell you whether any problems with the website or not. And because certificate authorities play a very important trusting role in the entire PKI and in the internet communication, there are lots of attacks on different certificate authority itself. If you look at here, let me tell you briefly. NIC, which is the National Informatics Center, which is one of the intermediate certificate authority in India, has fraudulently issued digital certificate for Google and Yahoo. What happened was some hackers compromised the intermediate C of NIC and started issuing digital certificate for Google and Yahoo. And after a while, Google found it and immediately our Indian root CA, that stands for CCA, has revoked the permission for NIC. No longer now NIC is valid. So in this, at the time, what happened in 2014? These three certificates of NICs, because NIC was maintaining three different intermediate certificate authorities. All three of them were revoked and immediately added into the revocation list. So there are also another instance where Symantec and others also found to issue digital certificate without doing a proper background check on identification of the entities which are requesting the digital certificates. So you can read more about the whole issue here and how Chrome has removed those root and intermediate certificate from the root store. And after that, Symantec was acquired by DigiSet and it has been addressed. And in fact, our own website certificate also we had to get reissued by DigiSet, which was initially issued by DigiSet, Symantec. And here what I'm showing here is the root C of the India, and as the name says here at the top, we have controller of certifying authorities in India, which authorizes or gives licenses to different intermediate certificate authorities for issuing different kind of digital certificates. So these are all different organizations which have got licenses to issue digital certificate. Also, there are many different classes of digital certificates. So far, I was talking about is only TLS or SSL certificate, which are used by web servers for having a secure communication with the clients. But also there are also digital certificate which are used by like Apple, Android, and Microsoft, where they use the digital certificate for signing the drivers and signing the source code or the executables that you install in your computers. That these are called code signing certificates. And also there are also digital certificates that are used to give time stamping, to say that so and so document is valid on so date. So we have time stamping services also possible. And also as an individual or as an organization, if you wanted to have a digital signature certificate, that means you wanted to digitally sign documents like PDF files and other things, you can also get a different class of digital signature certificate issued by different license certificate authorities. Like for example, Indian Air Force can issue digital signing certificate only to their staff. But if you wanted to get, maybe you can go to, I don't know, maybe vSign you can approach, and other one is eMudra. So they can give you digital signature certificate using which you can digitally sign the documents. And the root CA of India is listed only in the root store program of only Microsoft. So that could be the one of the reason why there are not many players who are actually purchasing or buying digital certificate from these license certificate authorities. And as I was mentioning, because of that issue with NIC, NIC stopped completely issuing any more digital certificate, and also I think you can see TCS, some of them also stopped doing this business of issuing digital certificates. So in summary, we have looked at the entire public key cryptography in the course so far, which is very powerful and use public key cryptography everywhere when you are talking about, because it is addressing one other problem of having not having a same key at the both places. But still, one problem that you face with public key cryptography is the problem of how you distribute the public key. That has been addressed using this chain of trust as by using something called public key infrastructure, where we are relying on third party attestation of your identity and your access thing. And there is a lot of criticism of it becoming a big business that has been kind of addressed with Lattice Encrypt, which has become of late the de facto open certificate authority out there. And as I was mentioning, we can use the digital certificate even for many different purposes. And eSign is a very recent initiative of the Indian government, where if you look at when you're talking about eMudra, they don't issue digital signing certificate to you just like that. You have to go to their office and you have to show your different documents and prove your identity before they issue a pen drive which contains the private key and other things. Because it is not scalable approach, they started a new process called eSign, where they are able to issue the digital signature certificate electronically. The way it is being done is they will record your video feed and other things as part of an online meeting, and also they will check all the documents, and everything is done in a remote manner rather than physically visiting the offices of these companies which are authorized to issue the digital signature certificates. Because digital certificate authorities and the PK has become very powerful, and there are also lots of attacks and there are a lot of issues. There are also many efforts to police how the certificate authorities function it. And if you start looking at the guidelines that certificate authorities has to follow, that are defined as part of the CAB, that is Certificate Authority and Browsers Forum, these are very stringent, and each of the organizations which are getting are participating in this certificate authorities program has to follow stringent audits of entire processes and have to comply with all the regulations. Otherwise, they end up losing their business and reputation. So it is all kind of a trust, and it is a kind of a hierarchical and a centralized trust. And I have not talked about, and also there are also interesting models like when you look at SSH and when you are looking at that GNU Privacy Guard and Pretty Good Privacy, they use entirely different kind of trust models. In the case of SSH, on the first time when you are connecting to the SSH server, then you trust the public key of the server. There is no other way you use any certificate authority out there. In the case of PGP, then you trust the person who is giving digital certificate or attesting somebody's digital certificate. So that is called a web of trust, unlike a chain of trust that you use in the case of public key infrastructure. So I will talk about this bit more as we go forward, but otherwise there are many different ways of issuing the public keys and trusting somebody else's public key, but still there are lots and lots of issues one has to deal with as you go forward. And these are all very interesting references. I hope you can get some time to go through that. And I'm stopping